Do you struggle with acid-base titration, molarity, or getting answers in titration calculations? In this video lesson, I will show you the fastest and simplest method to solve titration calculations step by step, which is perfect for your chemistry practical examinations. So stay with me. This practical class will change everything. You're welcome to WAEC Chem Clinic, where chemistry becomes crystal clear. In this lesson, you will learn the basics of acid-base titration, titration formulas, and calculations. In this class, you will understand how to solve questions quickly and accurately, and I will point out the common mistakes students must avoid in the chemistry examination. Make sure you watch till the end for powerful tricks. And don't forget to like and share these video lessons with your classmates. In acid-base titration, a solution of known concentration is known as the titrant, while the solution of unknown concentration is known as the analyte. So what is concentration of a solution? Concentration of a solution measures the amount of solute dissolved in a specific amount of solvent or solution. There are two main concentration terms we need to consider in acid-base titration or volumetric analysis. The first one is molarity, which is the ratio of the mole of solute to the volume of solution. It is measured in mole per dm cube. While the second concentration term is mass concentration, which is the ratio of mass of solute to the volume of solution. It is measured in gram per dm cube. How do we determine the molarity of a solution? The molarity of a solution is the ratio of the number of mole of solute in mole to the volume of solution in dm cube. How do we convert from cm cube to dm cube? Note that every titration calculation you are expected to convert from cm cube to dm cube by doing what? That's right, by dividing by 1000. Also, note this for your exam. During volume conversion, recall that 1 liter is equivalent to 1000 cm cube, which is also equivalent to 1 dm cube. Okay, so 1000 cm cube is 1 dm cube. Since 1000 cm cube is 1 dm cube, in order to convert from cm cube to dm cube, we are expected to divide by 1000. So can we consider this expression? 2 moles of salt in 500 cm cube of solution. What is the concentration of this solution? Note that molarity equals number of mole of solute over volume of solution. Can we determine the concentration in mole per dm cube? Yes. Concentration equals the number of mole over volume. The number of mole from the expression is 2 moles. So we have 2 divided by volume of water, which is 500 cm cube. What are we expected to do? That's right, we're expected to convert from cm cube to dm cube by doing what? By dividing by 1000. So we have the volume 500 divided by 1000. That will give 0.5 dm cube. Okay, since the volume in dm cube is 0.5, can we introduce it into the operation here? We have 0.5. So 2 divided by 0.5, that is 4 mole per what? Per dm cube. That's right. Okay, so the concentration of the salt in 500 cm cube of water is 4 mole per dm cube. Make sense? Can we consider the second dissolution right here? 1 mole of sodium hydroxide in 2 dm cube of water. But note that the volume of water required for dissolution is in dm cube. So there is no need for volume conversion in this case. So we have 1 mole over 2 dm cube. So 1 over 2 will give 0.5 mole per dm cube. So the concentration of sodium hydroxide in this dissolution is 0.5 mole per dm cube. Makes sense? Moving on, can we determine the mass concentration of solution? We have two formulas to determine the mass concentration. We have the ratio of the mass of solute in gram to the volume of solution in dm cube. Also, if molar concentration and molar mass of the substance is known, we can use the formula right here. Mass concentration equals molarity times molar mass. Molarity is the concentration in mole per dm cube, while the molar mass can be determined once the compound is known. Like we can observe in the second expression, sodium hydroxide is a known compound, so we can determine the molar mass once the compound is known. Now let's determine the mass concentration of sodium hydroxide in this solution. So we have the expression mass concentration equals molarity times molar mass. This equation is suitable. Can we observe closely? The molar concentration of the sodium hydroxide is 0.5, but the molar mass is unknown. Let's determine the molar mass of sodium hydroxide. Sodium hydroxide, we have atomic mass of sodium is 23 times 1 plus the atomic mass of oxygen is 16. We have 16 times 1. Also, the atomic mass of hydrogen is 1. We have 1 times 1. So this will give us 40 gram per mole. So that is the molar mass of sodium hydroxide. Since the molar mass is known, we can determine the mass concentration. We have mass concentration equals molarity times molar mass. The molarity is 0.5 and the molar mass of sodium hydroxide is 40. So 0.5 multiplied by 40 we give 20 gram per dm cube. The 20 gram per dm cube is the mass concentration of sodium hydroxide. Can we interpret the answer right here? 20 gram of sodium hydroxide was dissolved in 1000 cm cube of water, or we express this in dm cube. So we are going to say that 20 gram of sodium hydroxide was dissolved in 1 dm cube of water or solution. Moving on, can we consider the CYK1 question? What is the mass concentration of 3 gram of sodium hydroxide dissolved in 250 cm cube of water? I would like you to pause the video while you attempt this question. Can we solve the question together? What is the mass concentration of 3 gram of sodium hydroxide? So the mass of solute is 3 gram. So we have the mass of solute right here. And the volume of water is 250 cm cube. So all we need to do is to convert the volume from cm cube to dm cube. By doing what? That's right, by dividing by 1000. So when we divide 250 by 1000, we have 0.25 dm cube. So the unit has been converted from cm cube to dm cube. So which formula is suitable for determining the mass concentration of this solution? We have mass of solute over volume of solution. So this is the right formula to use. We have mass concentration equals mass of solute over volume of solution in dm cube. So the mass is 3 gram over the volume of solution is 0.25 after converting the volume from cm cube to dm cube. So 3 divided by 0.25, we have 12 gram per dm cube. Okay, can we interpret the final answer? We have 12 gram of sodium hydroxide was dissolved in 1 dm cube of water, or 12 gram of sodium hydroxide was dissolved in 1000 cm cube of water. The expression remains the same. 12 gram in 1 dm cube is equivalent to having 12 gram in 1000 cm cube. Makes sense? Moving on, can we consider this practice question? The question is on titration calculation. We have the acid right here, which is the HCl, and we have the sodium hydroxide in the other container. We can observe that the volume of the acid is determined by titrating the HCl against sodium hydroxide as shown in the diagram. So before the start of the titration, we introduce an indicator into the base. Since the concentration of the base is unknown, the base, which is sodium hydroxide, is our analyte, while the acid is the titrant, because the concentration of the acid is known right here. That's 0.5 molar. So we are titrating the titrant against the analyte. An indicator is introduced so as to signal the color change at end point. So the suitable indicator for the titration of strong acid against strong base is either methyl orange or phenolphthalein, because any indicator is suitable for the titration of a strong acid against strong base. In this titrimetric analysis, we made use of methyl orange indicator and we got the volume of acid used as 30 centimeter cube. So the 0.5 mole of the hydrochloric acid was prepared using the standard volumetric flask. So we have 0.5 molar of hydrochloric acid, and after titrating the acid against base, we have the color change as orange. In some cases you can have red depending on the condition of the solution prepared for this titrimetric analysis, but right here I'm having orange coloration. Okay, if a phenolphthalein is used for this titrimetric analysis, on addition of the phenolphthalein to a base, the color changes to pink. And when you titrate the solution of base which contains phenolphthalein with an acid from the burette, at endpoint we have a colorless solution after an acid has been added to the solution of base containing a phenolphthalein indicator. So when phenolphthalein is used for the titration of a strong acid against strong base, we have the color change from pink to colorless. But in an instance whereby a methyl orange is used for this titrimetric analysis, we have the color change from yellow to orange, as we can see right here. So what is titration? Titration is the process by which solution of known concentration, which is the titrant, is used to determine the concentration of the unknown solution, which is our analyte. From the expression on the board, I've been able to deduce a practice question for this titrimetric analysis. We have, if 30 cm cube of 0.5 molar hydrochloric acid is required to neutralize 25 cm cube of sodium hydroxide completely, find the concentration of sodium hydroxide. The first thing we are expected to do is to write a balanced chemical equation for this reaction. We have hydrochloric acid reacts with sodium hydroxide to give sodium chloride plus water, H2O. Okay, so from this equation we can observe that we have 2 atoms of hydrogen on the reactant side and 2 atoms of hydrogen on the product side. 1 atom of chlorine on the reactant side, we have 1 atom of chlorine on the product side. 1 atom of sodium on the reactant, 1 atom of sodium on the product, while we also have 1 atom of oxygen on the reactant side and 1 atom of oxygen on the product side. So which implies that this equation is balanced. If you do not understand balancing of chemical equation, check the link in the description below to understand balancing of any chemical equation. From the balanced chemical equation, we can determine the mole ratio of hydrochloric acid to sodium hydroxide in the equation. So we have the stoichiometric mole is 1 mole of hydrochloric acid reacted with 1 mole of the sodium hydroxide. So the next step to take is to extract the values from the questions, that is the parameters needed to calculate the concentration of sodium hydroxide. For this neutralization reaction, the concentration of acid is known, while we are expected to find the concentration of base, which is unknown. And we expect to use the known concentration to determine the unknown concentration of the base. From the diagram right here, we have the volume of the acid used up during titration is 30 cm cube. So we are expected to convert the 30 cm cube to dm cube, 30 divided by 1000. So we have 0.3 dm cube of acid. And the sodium hydroxide here is the volume of base pipetted. So we have 25 divided by 1000. That's 0.25 dm cube of the base. So we've been able to convert the volume of the acid to dm cube and also the volume of the base to dm cube. Then the concentration of the acid is known, and we know the volume of the acid. Therefore, we can find the number of mole of the acid. That is the actual number of mole of the acid contained in 30 cm cube of the solution of acid used up. Therefore, we can determine the number of mole of the acid. We have number of mole of HCl equals concentration times volume. The concentration of HCl is known, that is 0.5 molar. 0.5 times the volume of the acid consumed is 0.3 dm cube. We have 0.3. So by the time you press the calculator, we have 0.015 mole of what? Of HCl. So that is the number of mole of acid used in this titration. In the balanced chemical equation, the ratio of the number of mole of acid to base is 1:1. So we have 1 mole of acid, HCl, requires 1 mole of sodium hydroxide. Therefore, since they have the same number of mole, we can equally say that the number of mole of the base, which is the sodium hydroxide, is what? Equal to the number of mole of the acid, 0.015 mole of sodium hydroxide. This can be deduced from the stoichiometry, ratio 1:1. Okay, now can we determine the concentration of sodium hydroxide? Since the number of mole is known for this question, we have the concentration equals number of mole over volume. Okay, we are still considering this formula for molarity. So the number of mole is 0.015 over the volume of the base used in the titration is what? 0.25. So we have over 0.25. So this will give 0.6 molar or 0.6 mole per dm cube of what? Of sodium hydroxide. So we've been able to determine the concentration of sodium hydroxide for this titration. So the concentration is known for sodium hydroxide. Make sense? Kindly make the following adjustments on the values of the volume determined. This should be 0.03 dm cube, and also we are expected to have 0.025 dm cube for the volume of base. So we are going to have 0.03 times 0.5 right here. So we have the number of mole of HCl to be what? 0.015. The final answer is still correct. And also we have the volume adjustment here. It is divided by 0.025. So the final answer is 0.6 molar. Make sense? Note that the formula CAVA over CBVB equals NA over NB can only be used by secondary school students and students preparing for O-level examination. This should not be used by advanced level students. So the formula to be used by advanced level students, students taking IJMB examination, JUPEB examination, and other advanced level programs should be the step-by-step formula that we've discussed in this video lesson. So do not use this formula as an advanced level student. Make sense? So if this formula is used, the concentration of acid is 0.5, while the volume of acid is 0.03 dm cube. The concentration of base is unknown. The volume of base is 0.025 dm cube. The number of mole of acid is 1, while the number of mole of base is 1. So you can attempt this using this formula. So the final answer will be 0.6 molar or mole per dm cube of sodium hydroxide. So the determination of the concentration of unknown solution has been simplified in this video lesson. Make sense? If you now understand acid-base titration and titration calculations, don't forget to like and share this video lesson. Comment titration mastered if this helped you. And don't forget to subscribe to WAEC Chem Clinic for more practical tutorials. In the next video, I will be teaching you salt analysis and gas test. So watch out for salt analysis and gas test in my next video lesson. Remain blessed.